Hello everyone, welcome to my channel. So today we are going to do Leetcode bi-weekly challenge second question, and that is range product queries of the bar. So basically before starting this question, let me introduce you with Newton School coding competition, about which you can figure out in the description below. So in that description you can find the link for the same, and in that link you will be having all the details for the competition. So the thing is that you can register all for free, and then doing that particular competition you can, when you would be in the top performance, then you will be getting exciting prizes for the same. So this was all for the Newton School coding competition. And now let us start with this particular question. So in this question, let us first read this question, then about the time constraint, and then about the examples which are being given to us in this particular question. So here, given a positive integer and there is a zero index array called powers. So basically these powers we are required to make. So that is the thing, and how we are required to make. So about that, they are going to tell us. Composed of minimum number of powers of 2 that sum to n. So basically the power of 2 which are being there. So those will be stored in the powers array, and that will add up to the n which is being given to us. So the array is sorted in non-decreasing order. Basically it is sorted in increasing order, and there is only one way to form the array. So basically, all the powers of 2 which are being given to us, not given to us, the thing which we will be figuring out, those all are unique. So now you are also given a zero index to the integer array queries, where queries of I equals to left I, right I. So that is the thing. Now each query of I represent a query where you have to find product of all the powers of j with left I, and that left I will be less than j, and it can go up to right of I. So the thing is that query would be given to us, and in that query, whatever indices which are being given to us, so from that indices till that index, we are required to find our answer for this A. And how we are required to find the answer, that they are telling us now, that return in area answer equal in length to the queries, where answer of I is the ith query. Since the answer ith query may be too large, because answer of I should, so each answer of I should return modulo of 10 raised to 9 plus 5, plus 7. So because they would be large enough, because we are multiplying them all together, so that's why they could go up to much larger. So that's why we are just required to do modulo with this number, so that it could come in the range of integers. So that they want to convert. Now it is first example. So before example, let us check with the constraint. So constraint is that these constraints are in such a manner that the n could be 10 raised to 9. So because of that going to 10 raised to 9, so it will completely be a 32-bit integer, which is being basically that powers array which we will be making, that could be up to, means it will be up to till that 32-bit integer. And then now comes the part for this particular, that queries dot length, which will be means this particular queries which is being given to us. So that length would be 10 raised to power 5. That simply means that these things mean these pairs which will be given to us, they could be at max 10 raised to power 5 pairs. So the thing is that because of this context only, rather than going ahead with the n square solution, we are required to complete this particular question in order of n solution. And now the that power dot length. So basically, our start of I, end of I will go till powers dot length. So whatever power array which we will use, and the start and end which is there. So basically, yeah, basically they are saying over this left only, which they are stating here as start and end. So this question is about like this n is being given to us, right? And these queries are being given to us. And one power array that we will be forming. So that power array would be containing all the multiple of 2, and those multiple of 2 will be, after adding up them, we will be getting this particular n. So basically all those powers of 2, not because we can't see them either multiple or factor, because multiple factor will include 2 into 3 also, but we don't need 2 into 3, we require 2 into 2, and then 2 raised, basically we require 2 raised to power 1, 2 raised to power 2, 2 raised to power 3. That is the thing which we require. So that's why we will be saying the most appropriate term which is required to use here is power of 2. So that powers array which we will be forming, that will be consisting of the all the power of 2. So now here comes the part that for n equal to 15, powers equals to this particular, right? So it can be shown that power cannot be smaller size. So that is also thing. Now according to this first query, so first index is 0 and second index is 1. So that simply represents that we will be going in our power array, right? So whatever is there at the power 0 and whatever is there at the power 1, we are required to multiply them both and required to store at the first index of our answer. So that is they are doing here. So that is we will be doing and returning as our answer. So this is the thing we will do then here. I is equal to 2 and I plus 1 equals to 2. Both of them are right. So that's why we will be directly heading towards this power of 2 equal to 4 and that will be our this particular answer. And then for this, what we are doing is we are going from 0 till 3. So here the thing is power of 0 into power of 1 into power of 2 and into power of 3 and then we are multiplying all together and getting this 64. So this is the thing which we are going to do and that will be stored in our answer here. So each answer modulo 10 raised to the 9 plus 7 yields the same answer. So this is being returned. So this is the thing which we are required to do at this particular point. Now comes this part. When n equal to query is equal to this, right? So the thing is that output will be 2. Now comes the part that for n equals to 2 and power is equal to 2. So this is a straightforward because here power of 0 until power of 0, right? So both of them are same only. So only power of 0 would be considered. At power of 0, and when we go ahead for this n equals to 2, so n equal to 2 directly is for this power of 2 only. What I mean to say is, see, for this previous example, when it was there, so for 15, this 2 raised to power 0 that is equal to 1. So this one is also power of 2, right? Then plus 2 raised to power 2, sorry, 1 equals to 2. Then it was 2 raised to power 2 that was equal to 4. Then 2 raised to power 3 that was equals to 8. So after adding them up, it's 12. After adding 3 and then after adding up them, it is 15, right? So this was being stored in our power array. But now when n was 2, right? So we're taking that which power is there, which will, after adding up them, we get Rn, right? So because of that only, then we figure out that 2 raised to power 1 is the only power which we can store here. So we got this and then this is what we got as our answer. So that was the thing. And according to that only we are required to store. So now here the main portion of this question is that we are required to check that what is our n and according to n only by doing the bit manipulation we are required to store our in our powers array. So that's the thing. So here the thing is that see, before going ahead with this coding part of this question, one thing I want to clear that when n equals to 50 means whatever n is there. So what we are required to do is we will be required to do this thing, means basically checking for the set bit. If that is not equals to 0, then we are basically pushing that particular into our powers which is being there. Powers dot push back, that which will be done here. Basically, oh, so basically this particular thing is required to be pushed into our powers and from this only, when this power is completely done, then after that it is straightforward required to be done for this particular thing and this particular thing and this particular thing. So that's the thing which we are required to do here. So now let us go ahead with the coding part of this particular question and after coding we'll discuss about the uh, time complexity and space complexity for the thing. So now here uh, as per the question, we are required to do modulo with the same, right? So that's why we are taking like this. And then here the vector is for the powers which will be there. And this is for the answer. So here we are creating the powers array. How we are going ahead is We are taking for the 32 bits because as it is 10 raised to power 9, so it will be going till 32 bits only. And then after checking that if that particular bit is set or not, starting from 0 and going till 31, if that 0th bit is basically set for this n, right, and this simply represents that it is set, then we will be pushing that particular left shifted 1, means now when 1 is left shifted by 0, so that will be 1 itself, right? When 1 is basically left shifted by 2, then it will be, because this left shift simply represents multiplying by 2. So that we will be adding up here. So that's the thing which we are doing here. And then when this particular power array is ready, then we are required to go straight forward. We will be picking up each query from the same. So for each query in this query, and you are already knowing that it is something like this. So this particular Q will be pointing to this particular, and then our I is equal to Q of 0. So whatever 0 is here and 1 means basically indices which are there 0, 1, 0, 1. So Q of 0, and this long T is equal to this particular I plus plus. Now comes the part. Uh, Now whatever index was there, right? So we are going ahead with the same. So now we will be coming into this particular while loop, and then we will be going till Q of 1 means basically index of this particular. And then here we are basically multiplying with the whatever was there in the products array which is being there, and doing modulo for the same because it could exceed also from the range of n. So that's why we are doing modulo. So it remains in the range of n. And then at the end we are pushing to our answer for that particular query. And then when this particular for loop ends, then we are returning our answer. So this is the thing which we are doing in this particular question. So now comes the part for D, time complexity. So here you can take it is time complexity of order of 32. So which is basically order of 1 only. So here the time complexity comes, the time complexity equals to order of n. So n refers to the number of queries which are being given to us, number of queries, right? And now comes the part for the space complexity. So space complexity is because of this variant only. This answer is basically this form only. So that's why we won't be considering that as the space complexity. So for this part, here you can clearly see that it will be storing cell at max till 32. So that's why the space complexity also contributes to order of 1 only. So now comes the part that final time complexity is order of n, where n refers to the number of queries which are being there, and the space complexity is basically order of 1. So this was all for this particular question. I hope you like the explanation. And if you like the explanation, please do like and subscribe to my channel. And also do share among your friends for the same and for the better use of this channel. So this was all for this. So yeah, this was all. Thank you.